Hello, are you joining?
Hey, Yogesh.
Hey.
I actually can't stay today. I just I have a urgent thing that I have to do. So I just joined to say that.
Hey, Vilas, yeah.
Yeah.
Thanks.
Yep.
Just a quick note. The final slides for OCP Global Summit are due on September 29th, which is like 14 days away from now. Just wanted everyone to know. I think we are on track, but it's a reminder.
Okay.
Hey, Scott. Hey, Mark. Drew is here. Hey, Mark, I know you must be happy with the rain that we are getting here in Houston.
What rain?
What?
Yeah, no, it hasn't rained. It here it hasn't rained at all.
Man,
Kingwood got 3.5 inches yesterday. We got nothing.
I'm in Sugar Land, and it's really pretty right now. It's still raining.
I talked to Kevin this morning. He is, I don't know, 3 or 4 miles away from me. He got hammered. He said, they basically got a 15-minute downpour.
Wow.
We have not had a trace, not, we haven't had essentially no rain since July, early July. And the average temperature has been over 100 every day. So we're just baked,
I'm sorry, man. I know I'm happy because we really needed the water because we're under the draft conditions now. It's been in Sugar Land, right?
Yeah, it's been crazy hot. Very little rain for most of Houston, right? So I'm glad somebody got something, but it hasn't rained here.
Well, I hope so.
I hope we'll get something.
For what it's worth, my wife had a flight canceled taking my son to college because her flight through Las Vegas was canceled because of a hurricane, or a typhoon. So, pigs are flying. There's some strange weather.
Literally, right?
I mean, like what? This is Las Vegas? Did what?
I know, right? Hurricane in Las Vegas. Wow. I know of different kind of hurricanes in Las Vegas, not that kind that cancel the flights.
Yes, it was bizarre.
Vegas is a desert too. I mean,
I know.
It can rain in Vegas and you cannot get wet. Literally.
The burger rain.
Well, it's just so dry. It's high desert, so yeah, very very different. Down here, the humidity is normally nearly 100%.
She told me your flight was canceled. And, my head about exploded.
Very unusual.
Jerry, just curious, Jerry, you're based where? In Colorado, is it? Drew would know. I don't for sure.
Who? Jerry? Jerry Sanders?
Yeah.
Jerry is in the like Dallas area.
Oh, is it? Okay. I didn't know.
I mean, they were in Richardson, but I think he's in Plano now.
Yeah, we just moved to Frisco, which is just north of Plano.
Oh, you moved. Okay. I just can't. You all have moved so many times, Jerry.
We have. That's our 4th move in the last 15 years.
And with all the labs, and hardware you all have. That's wow. Anyway, so some more Texans. And
Yeah.
Scott, you're in Texas too, aren't you?
Yeah, he's in Austin.
Yeah. So we have a lot of Texans on the call today.
but none are actual Texans.
Oh, really? None of you all?
You don't have to rub it in, Jerry. I know. Anyway. Hey, Rama. Hey, Anil. Good to have you.
Guys. Who is in Austin? Yogesh is Houston, right? Yogesh, you're Austin.
I used to be in Austin along with my buddy here, Scott, but now I'm in Houston. Yeah. Yeah, my wife told me Scott is trouble. Move as far away from Scott as possible. Just kidding.
Well, so I got a notice, and Yogesh, I was going to get a little bit to business from Amber. We got to get our final slides in for the global summit at the end of the month.
Yeah, 29th. Right before you joined, Drew, I was telling everyone as a reminder. By the way, Vilas joined for a minute. He said I cannot stay. But yeah, I was telling at the time that our final slides are due on 29th.
So I guess what do we want to tell folks? Take a pass through them. We know we kind of know what needs to be done.
Yeah. So today is 15th. Why don't we review our slides on 22nd? Would that work? And then we still have one more week before we have a summit.
Okay.
Yeah. Yeah.
And I guess I need to look at what the review cycle looks like, but that sounds good to me. And if it's earlier, we may have. I guess, but we'll see. Let's talk next week about it. And
yeah, we'll review here in this group, and then we can do our respective corporate reviews or legal reviews if needed. I don't anticipate for this group though, but we can do that, and we'll still have a week for that.
so I don't know what other topics we had today. I did have a picture that I wanted to show folks today. I showed it to Anil just saw it in the previous meeting, but on how analysis, I'm getting some feedback on how analysis should work. And I'll have more detailed stuff to share with you soon, but I'd like to share a picture sometime today, if you all are okay with that.
There's one topic I want to bring sometime, Yogesh, maybe logistic kind of topic related to the work that we are doing versus the GPU versus REST API. I'm trying to get my head around, and I'm getting confused.
Well, we can speak to that. Some of that's in the slides too, Anil, that we've reviewed. So you might have missed those meetings, but yeah, let's talk about that. That's good to make sure we're all aligned on it.
Yeah, no, that's a really good point, and Anil, I can assure you, you're not alone.
Yeah.
We all owe it to the community to do a good explanation of how these puzzle pieces fit together. And a lot of that, I think we intend to accomplish during the RAS API talk in the Global Summit. So Anil, if you have specific concerns, we are all ears, and Rama, you too. But I think
one thing is good. It's good that like we converge all our thoughts here before Global Summit, and whatever we agree, like we should put like one face and one voice when others support it. Okay, I know we have like converging points somewhere, right? Okay, yeah, like bringing up those points here before the global summit is like a good idea rather than adding
So
those
this
kind of thoughts later. Yeah.
So this is John. So I think I know, and I had a short discussion earlier when we were talking about cloud service models, trying to fit that into our management. So I'm going to show you a couple of slides which are not done, but is my attempt to get the hardware management project leads to understand how what is happening to the organization. Usually once a year in January, we do a strategy to figure out where everything fit in. And this year, we started it and we abandoned it because we said so many work streams of trying to get into hardware management that we're going to let this work open source, right? We'll let the open source community figure out which way we're going instead of trying to mandate where we're going. So, so we're doing this like afterwards. So all this has happened, and now we're trying to fit this in. And when I saw the presentation to the OCP Summit, it was kind of confused. And I said, if we don't start with a diagram that looks like this, then nobody will understand where anything fits in, guys. So I'll explain this to you. And again, I'll tell you that it's not complete. So what is blue is all the existing sub-projects within hardware management. And what is kind of yellowish is the existing work streams. So we have a work stream for RAS, we have a work stream for fleet memory fault management, which is within fault management. So it's a work stream within a work stream, which is fine. We have a manageability profiles, which spans in-band and out-of-band, and we have this modular management sub-project, which does the DCSCM and run BMC. Given that, and then we have run RMC, device manager, which does the rack management API, and then the open source developments below that. So what is approaching quickly is GPU management, which Anil alluded to. We need to fit that in. We have server component resilience, which was kicked off at the same time GPU was. And then we have the satellite management controller, which kicked off last week when those were contributed. So these three have all been contributed in the last month, maybe 2 months. And cloud service model is trying, as of this morning, to formally request that they come into the hardware management project. So this is my diagram saying, okay, this is how we're trying to partition things. And this is more of a charter diagram so that we understand who has charter for what, and we don't have overlapping charters. And you can't draw this diagram enough to get everyone's charter to overlap. So I'm not going to try a Venn diagram at all because GPU management has RAS. The RAS API is over here. I know you guys have been talking to GPU management and to RAS. So this is just a diagram for the project leads to understand that you guys write charter, right? Make sure we don't have charter overlap, because if you don't fix it now, you're going to fix it later when two groups think they have charter and they run into each other with conflicting documents.
Hey, and John, I've got another view of the same one that's more of a fault management centric view. If you're interested, we can kind of compare.
Let me show you the next diagrams, and then we'll come back to you. Whatever you have would be great, because I did this I think last week after I saw the OCP a global profile session. Okay, so now you have that. Now you have charter. Now you have document ownership. So this lists out all the documents that each group owns. So yes, GPU still has this RAS management document that they contributed, and RAS API has this RAS API spec. And then the next diagram I did just since the morning, because of what Anil said, saying, this doesn't really fit right. And we had confusion on this diagram, whether this was a DOM charter diagram or whether this was an interaction diagram, which it is not. So this is my interaction diagram of who's working with whom. So I've got the profiles up here where everyone's kind of having a redfish profile, which is a great thing. Yes, I don't have a line from here to here yet. And then this is my cluster of where fault management is, where FMM is, and that you guys are working with the RAS API and GPU management. And these two have to be connected because these guys own GPU RAS, it's back, but these guys you own the API. And whatever improvement you have with this would be great. The rest of this is all trying to figure out where these other interact, whether they're self-standing and they're not really interacting, or they are in fact interacting. I think most interaction is occurring here. And then we have this management module, which is actually interacting with server DCMHS because it's a composable module.
So,
Yeah,
so
John,
John,
I think John, that's really good view of from OCP hardware manager perspective. And I think it clears some of the air for different projects and project leads, project members, what we are driving to. What I was thinking was also to translate that into what it means in terms of requirements. We're driving lots of requirements. What it means for, say, a CSP, what it means for accelerator vendor, what it means for silicon CPU vendor, right? That might also be another good view I've been thinking about to draw that. But this is really good, John. I really appreciate you kind of trying to clear some of the air here. There definitely is going to be some of the overlap and kind of cross-pollination of efforts, but I think that it's all good. It's positive.
So John, I have a question for you. In my mental model, the RAS API is another work stream from fault management, and the GPU management one kind of overlaps some with fault management, but it's not really a sub work stream, but it's, there, like if I'm drawing a vent, I guess I don't understand why RAS API is separate. When Antonio and I started it, we did it in terms of the overall fault management requirements doc, right?
That I don't remember, but it may very well be, right? So if you and Antonio have made this decision to move this into here, that's fine. But the way it was originally pitched and constructed was it was a work stream directly attached to hardware management.
And not only to that point, John, not only that, even GPU, Rama, you can correct me, but at least half of the GPU management, the RAS aspect of GPUs should be overlapped with fault management, and that's kind of how you have aspiration to drive.
Right. That's why we don't look at this diagram. We look at this diagram. Oops. This diagram as to who's working with who. So
2 points.
Right. So the point I have with this diagram is this decision is made by Jeff Otter and Hemel, right? And they need to understand how the group is structured. And if groups are, instead of people coming in and say, we're going to be in that work stream way down there, it's like, sorry, you don't have that choice, right? You have a choice of saying to Jeff and Hemel, we would like to come in, and Jeff and Hemel, being the project leads, figure out what charter you have so that you don't overlap with everyone else, and then they stick you in the right place. When RAS API came to me, I said, oh, you're right, we don't know where you fit in. So we'll connect you directly up to hardware management, right? And when you get momentum and figure out where you are, you can say, we want to be in the fault management. And then, I mean, Jeff and Hemel don't really care as long as there's a structure that they can understand who reports up to who, right? So if you and Antonio walk in and say, hey, we're attached to hardware management, we really want to be work stream within here, then ask it and we'll change the diagram and everyone's on the same page as to where you are.
Okay, I can talk to
Antonio. Right, this started, got my call because CSM, Cloud Service Model, came in and said, we are in fault management. And I said, you cannot say that. You can say you're in hardware management and then let Jeff and Hemel decide you're in here, but you cannot come in and say, we will only be here if we're in there. It just doesn't work that way. So So that's why. So yeah, I'm perfectly okay with moving RAS into here once Jeff and him are all on the same page.
I think, thank you. 2 points. I think I think RAS API, GPU RAS, I think those two are right now CLA based workstreams that are making it little complex. Like once like the complexity gone, like North Star goal or like next maybe 1 year, those will be open source based and like not even like CLA based. That's where that's where you will see like anybody from quality management work group can participate it, right? So open. That's where we should drive towards, right? Like the RAS API, everything should be like somewhere out of coming of CLA mode, because CLA mode is the one which is like limiting factor, like openly, like yeah.
So that's valid point about how work is being done, Rama, but I think how it affects the industry stakeholders doesn't
Yeah.
change
Doesn't
CLA
change.
and non-CLA. CLA just indicates that a group of companies have declared that, hey, whatever work we do here, we're not going to claim IP on that. But really, if we are driving it as a standard for OCP from OCP, then it doesn't matter whether it's CLA or not, right? Do you all agree?
Yeah, I agree that like how it impacts. I mean, yeah. But the only thing is others cannot provide feedback early. That is the limiting factor. Yeah. Like,
Right,
yeah,
and that's one of the issues with these guys, right? These guys work under a CLA. And so we make sure any attachments to them are understand that, because these guys just do things. They're a team of 20 companies all willing to work under a CLA to go to get this work done. And I think the rest of this is all free and open.
So John, help me understand this. Maybe I'm wrong, but I tend to think of CLA as a positive in terms of the work that gets done is not really it's free for industry to adopt. It's not limited by any companies.
No, it's not.
Right?
No. A CLA, okay. CLA documents are done in 2 ways. There's a CLA upfront that whatever number of companies sign to say, we are going to work together, and we kind of promise at the end that we will sign an FSA, which is the final spec agreement. Okay, the CLA says that we 20 will work together and we basically won't steal IP from each other because we're all going to give this away anyway, right? So that it protects all the people who enter into this multi-part NDA, if you wish to call it that, right? So they go and they work all this documents. It's hidden from people. Anyone who doesn't sign the CLA can't be in the room because they haven't signed this agreement to be mutually nice to each other. Okay, at the end, this document comes out and they say, okay, we're done. We all promise to sign the FSA. Everyone goes off and signs the FSA. The FSA is the one that says, we 20 companies have put all our stuff in here, and we are releasing any encumbrances on this data, so that when it gets contributed and someone finds it in the contribution database, the first thing they're going to ask for is, where's the FSA? Because FSA says, I can now take this document, design, whatever, right? And I can utilize it, and I will be comfortable that no one's going to come attack me with patent rights on any of this stuff because there's a FSA signed against it. So it's good. CLAs are good because it allows multiple companies to work in a kind of a comfortable environment that we're all working toward the same cause. But it's a negative in that it's closed, because if you say, I will not sign the CLA, then you cannot participate because you've not agreed to be a good citizen. Does that make sense?
Yes.
Okay, so now you just reminded me, RAS has a CLA. So how is that? Pardon?
Yeah, it does. It does. That's right.
Right. So if I put this within here, what are now the IP rights for people who look at the data that's coming out of here or not? And I need to go talk about Antonio about how this interaction occurs between a CLA entity right, and a non-CLA entity.
Well, and I can speak to that to
Put
some.
CLA on GPU management also right now. GPU management
Oh,
also.
okay, yes, yeah, right. So this is okay. So that's why I wanted to do this, was to figure out where all CLAs went.
Yeah,
So,
that's
so John, I don't see a problem in having a CLA work stream within the umbrella of a sub project
You
where there may be activities which are not on CLA. I don't see any problem with that.
Yeah. I guess I don't understand. So John, I guess what I would also say is, I have kind of a drawing that shows how the teams work together. In my mind, I see this team, the fault management team, as laying out a framework, and then these other efforts like filling in parts of the framework. The framework is incomplete. It's just a vague notion of how things work together. And then we got to go work the details out. And so the RAS API goes and works details out. And they'll come back with a spec at some point that's submitted. And if you're not in the CLA, you can't participate in defining the spec. But at some point we have an FSA, and we can publish the spec, and then we can say, okay, the spec is how we do this part of the fault management framework we've been talking about.
And just to add to that, before the spec can be published, the fault management core team need to review and at least give a green light, because it is really under the framework of fault management that we have been working on.
right. Okay. So that one, I don't want to take more time than the 30 minutes I probably have. Okay. This again, these are diagrams in flight. And they can maybe change, but there's a need to create this structure because a lot of what OCP does, right? And the only one main benefit of OCP is it creates a IP structure in which companies can work together in an open source kind of manner. And we have to maintain that integrity. Everything through, you may say, maybe you're right. We just need to understand when people are in the room, right? This stuff is CLA and this stuff still isn't. And we all know how to go deal with that.
Let me just add one more thing, John. When we started fault management sub-project, we had that discussion, and we consciously made a decision, well, we are part of OCP, we want to talk openly,
right,
and therefore we don't need any CLA.
Right, which is why you don't have a CLA here.
Right. And one last thing I would suggest, if I may, is the line that you're drawing for the fault management. If you encompass the other two things also, then this diagram.
I understand you need to change this diagram. I'm not going to change this diagram until I and Jeff Otter and Michael Shield all have a discussion about what we believe is right. Because
I'm just giving my input. That's it.
And I understand that. And so given that this is a CLA, this is CLA up to 0.7, I believe, and then it was contributed to OCP, which meant hopefully the FSA was signed, right? And that this is, sorry, our FSA didn't have to be signed, but the intent was to take this in at 0.7 and then allow a more wider audience to discuss taking it all the way to 1.0. So, okay. So I don't want to take any more of your time, guys, but this is stuff that some people are actually trying to do. So if you're concerned about not partitioning things right, we're trying to partition it correctly.
Yeah, John, would you mind if I shared another view of how I think these things fit together?
Oh, okay. So I'm done with my time. I don't want to take any more. Anytime you want to take, go right ahead and take it.
Well, I'd like to show a slide that shows how I think things fit together and see if my mental model matches other people's. So, because I think Anil raised a good question earlier, and we need to be clear. So I can't share until you stop, but I'd like to if I could.
Really? Oh, sure. I didn't know.
Yeah. No, Zoom's different. Who knows? Okay, so this is.
You are on mute.
Yeah, I don't hear him either.
I think he can hear. Now he's trying to unmute. He can't figure it out.
I think what happened is he has the audio from
Can
the.
you hear me now?
Yeah.
Yeah.
You know.
I hate that feature. I don't know how to turn that off.
It's by
Anyway,
default, right? Yeah, it happened last time also.
I could understand your
Yes.
lip service with lip movement. What do you think?
It's so frustrating. Okay, why? Anyway, so you know, like the way I see it is, we have this overall fault management effort that has a framework that says we want to get rich error logs from the vendors. We need their help, so we have their code logging them, and we want analysis tools that analyze them. And so we have a GPU fault management effort. Well, we want to do some things with the BMC and the hardware fault monitor. That's a place we need to do some work. We also have the RAS API, and I've kind of put this green oval in because the RAS API is really a driver in the BMC, and the interface is, to log things. And then I said, OCP fleet scale fault or fleet memory fault management is an analyzer in the analysis side of this. But to me, we've got a framework and we're filling in the pieces. But I don't want to step on anyone. If I've got the wrong idea, please speak up.
I think this is very good analysis of various efforts, Drew. I think to complete the picture from OCP perspective, we need to bring in telemetry efforts also.
Okay.
I think first, I really like the picture. Like you put exactly like where we are. I think bringing additional people, as long as there's no questions, I think first aligning on this one, like because that is important because we want to avoid like time to time like the questions. Yeah, this is really good.
I tell you what I'll do is I'll upload this onto our wiki or whatever,
Yes.
onto our share drive, and then send you all the link. And I welcome feedback. I mean,
Yeah. And one more thing you can add is other analyzers like GPU. There also you can put like GPU fault monitoring.
Right. And I would say the GPU analyzers would ultimately end up right like here, right?
Yeah.
Yeah. Okay, well, I'll upload this, but John, I'm not trying to step on your toes either. I've been puzzling this out myself and wanted to show you what I've concluded and see if it made sense.
I'm glad lots of people are puzzling, right? Because this is a problem that everyone seems to want to go solve. So we just want to make sure that all align.
I just want to remind everyone that from the CSM also we have some efforts which overlap with us. Invent is one of those, and Anil is totally plugged into that.
Yeah.
But then there are telemetry and overall management efforts. We probably need to consult with them also and figure out where they fit into the picture.
That's a really good point. I didn't put those in because I'm not.
Yeah, if you draw a cloud at the end right-hand side, connect to the cloud
Right.
provider infrastructure, then that is what the interface CSM is trying to define.
Sorry, say where is that right here?
Almost at the right-hand side of cloud provider infrastructure.
Yeah.
I think so. Drew, I mean, you are calling this cloud provider infrastructure, but you're showing a sub part of that, right? There is another part of this whole cloud provider infrastructure where we aggregate this information across multiple machines and do further certain things like monitoring and taking some fleet level actions and.
I mean, that's kind of right here, right?
No. Because he has this open BMC which runs in the BMC, right? CSM has the software agent which runs on top of the OS, which is not shown here, right? But that also is extruding telemetry data, which both gets consumed by these analyzers. So it's getting data from the BMC, right? Yeah.
That's right there. So I think, I abstracted the collectors away because that's not as far as I can tell, super central. You know, I thought we farmed that problem out to them. You know, they had it under control. So we're like, hey, great, you make a big collector and filter and everything, and then we'll feed it with stuff. But you know, maybe what we could do, I think we could highlight the areas where they're working and just say, you know, we don't have any detail for how the collectors work because we're not driving that directly. But I think we could mark the drawing up, or we could even add some stuff to the drawing if we need to.
Yeah, so Drew, maybe I have not seen the actual source of this diagram, source file. If you can share with me, then I can
Yeah, the
provide
source file is our requirements document.
No, it's a picture only.
Uh,
I think
uh-oh.
it's. I think you can double click on that. That should not be the case. Only
It
thing is
should-
it's a docs diagram, so it's a little bit different.
So you have to save it as a picture to put it in slides. I'm going to bite my tongue. But so
Just share this slide, Drew. Okay.
What I can do is I can share. I converted it to a PowerPoint image for something I was editing some time ago. I can share that.
But actually, can we? I would beg people, beg to start with the original drawing so that we can update our doc. You know, or I guess we can do it separately. But see, Anil, I just double clicked the picture in the doc.
No, what I was telling Drew was that I saw an option to save the original picture that you have here as a
Yeah.
PowerPoint diagram, which
You can do this.
Yeah.
You can download it.
Yeah, something like that, right? And,
But we could also, and we can also make a separate Google drawing too, if people just want to have a separate drawing. There's a Google drawing tool. It's the same thing standalone.
I'm talking about editing the drawing.
Yeah, that's what we're talking about. So,
Okay.
so Anil, this is editing.
No.
So-
Can you move around the boxes?
Yes, I'm about to add a box to it now.
No, not adding, just moving around. Like, can you edit this particular one? Like increasing the. Yes, see, I don't have that access. Maybe your copy has some. Maybe you have access to source. That's why you're able to open it.
Let me check that. I think you should, but let me check that again. I think you should. So,
Yeah, Neil Agrawal at Meta has editor access. I think. I'll send it to you. Oh, maybe not. Try again, Anil, here in a second. Try again. Apparently you didn't. I think I just updated your access.
Yeah, you might have given access to a copy which is not the same folder, looks like, but I still don't have.
I will. This is our 1.0 version, and they're all daisy chained to each other. So there's a link at the top of all of them.
Oh, okay. Now you just gave me, right? So hold on. Let me reopen it.
Yeah, you may need to refresh. But
Yeah.
for those of you all in that want to take a look at the doc and make comments and stuff, here's the link for your convenience.
Yeah.
hey guys, I need to drop early today, but I'll be happy to pick up next week. Like to know if I'll watch the recording of it.
Now I can open it. I have one open topic that I want to discuss. I don't know if you have time.
Real quick, Anil, I'll stay for your open. Yeah.
Okay, so the open is as of today, when it comes to the errors, corrected versus uncorrected, the standards are defined whether to route all the errors, either like a firmware first or OS first. We don't have any scheme defined where we can partition the error types and then reroute, let's say, correctable errors in-band to the OS and uncorrected errors to the, let's say, out-of-band BMC. So I'm just thinking,
I guess I'm not sure it's either or, Anil. It may be that we want to get the corrected memory errors in band and out of band.
So for some cases where we need to have that dissection anil, we do have shadow banks. That is one way of, I'm assuming your motivation for giving parallel access priority and ownership to both firmware and OS would be to avoid the race conditions and avoid cases where it's generally good to have overall access to one domain, say firmware first, but in some cases you need priority or equal parity given to the OS. Is that right assumption? So in those cases we have, if that's right assumption, then we have shadow register banks available. I just want to.
Yeah. So you're talking about something in the future. I'm talking about. So my problem statement is what we have today. There is a gap. The ACPI spec, the OSC OST method defined today, talks about either full control by OS or full control by firmware. And what we need actually is a error CVT granularity based control.
So what's the motivation again? What's the motivation here?
The motivation is that we still have to manage our fleet that exists today, and at least for next few years. And then the machines which are deployed are not going to switch over to this new method overnight, right? We basically, the fleet which we are deploying today, or we already have been maintaining, will have a life cycle of at least another 5 to 7 years. So during this time, we need to fine tune our requirements or specs so that we can implement a better solution than what we have today. While we are working on a new concept which will intercept in future, and from there onwards, the new fleet will continue with the new concept. But at the same time, we have the old fleet and a near-term fleet, which is still being deployed. We are deploying every day hundreds of racks, right?
Well,
and they'll continue.
Yeah, but I guess, Anil, the thing is, we can't change silicon. It's right. You're deploying it. It's silicon's frozen. So what can we change? Well, we can change software.
Yes.
But I guess the problem is that we don't have software infrastructures that are converging particularly. Some people use SMM to log errors. Some people are in-band, and if you want to go in-band, there are tools like EDAC, right? So I don't know if there's a problem we can do much here with. I guess our options are limited.
No, we can. That's exactly what I'm trying to bring here. That there are some baby steps, and also we can put a framework, a roadmap of how this body of expertise here can provide a guidance to the rest of the industry, how we can improve the fault handling infrastructure on the existing hardware by modifying certain software infrastructure. And what the API requirements would be, and what specs need to be updated, because today's infrastructure is based on existing specs, right? So we need a spec change, and then API definition that software guys can then start modifying the kernel patches and all that, right?
Right. So Anil, I understand better now, but what you're saying is to accommodate the proposed long-term spec changes and adoption thereof by various stakeholders, you want to propose another change in spec and adoption of that. Now, I think that just complicates things for those who are most impacted by the adoption. So we are talking of creating another set of requirements, baking those into specifications, and then adoption thereof by various stakeholders, silicon, operating systems, whatnot, right? OpenBMC. I'm not convinced that actually, I mean, we're kind of creating a racing parallel path. Maybe I'm wrong, but I would like to
Yeah,
understand.
not parallel path. In fact, if we don't work on the problem that we have today, then the future problem solving is kind of becomes a diminishing return, because by the time we get there, we'll have a different problem. And then
But I
again, we have to
guess
work on that.
but like Anil, what we did is we have an infrastructure that's really similar to the picture I showed earlier. It's just that we used SMM to do our error logging. We're not going to open source that, but and the solution isn't nearly as good because we don't have as many error registers as we'd like. There's stuff that we're missing, but I guess what I don't understand, we're ready. We when the future comes, we're gonna take out the bits of the stuff that we had to work around and replace it with the stuff that works well. So now, if you were to tell me, hey, I want to build up the in-band error logging infrastructure plan some more because I have in-band use cases, then sure, but we can do that long term and then see how far we can get short term with it.
Mm-hmm.
I mean, I'm not pushing back. I just don't understand what we could do in the short term other than what we're already doing.
Yeah. I mean, the point is that we are developing the solution. When I said we now in the meta context, and we will deploy that, right? Because we have to manage the fleet that we are deploying today.
Now, yeah, absolutely.
And now the question is, can the rest of the industry leverage on that? And I've been thinking through, well, if you can drive through OCP, the spec change requirement, and that way it's open to rest of the industry. And we probably are not the only one who are implementing this kind of solution we are implementing.
One thing we could do, Anil, in the short term is we could look into error logs and what we want to put in error logs, and build analyzers for them. The only catch I see to that is that starts involving CPU vendor IP. So, it's a little tricky, but I could see us, like working with vendors to develop a common CPER format that we log ourselves and send to their analyzers. And then, because what happens is at some point, they're going to start gathering the data for us in their CPER format and analyzing it. But if we can precede them and start doing the analysis with them earlier by just logging things in a way that the vendors can take data, that's great. So that is an area we could get started now. The catch is we can't do it here too openly because, I don't know that Fintel and AMD are going to describe all their error logging registers in great detail. You usually need an NDA, to get the details. So I'm open to your idea. I just don't see an obvious path.
Mm-hmm. Yeah, my ask is really much more specific, actually, is to be able to partition the error reporting flows on a per severity basis, which doesn't.
Sorry, on a what basis?
Per severity basis. Corrected versus uncorrected non-fatal versus fatal. Today, the spec, the way the interface defined is a all or none. So everything go to OS or everything goes to BMC.
That's not actually how it's written. Everything goes to both, and you can cloak. So if I'm a server vendor and I'm worried about customers insisting that we replace their DIMM in the first radiation strike, I could cloak the memory errors and hide them. But when we say that we're logging everything out of band, we're not saying nothing comes in band. So the long-term solution is sending things both directions. The intermediate term, the thing that we're doing right now with SMM in our code, is up to us, and we expose what we want, and what we expose to the OS as we run shouldn't really matter to you, right? You do what you want, we do what we want, no big deal.
Yeah, maybe let me make it even more precise. For the PCI errors, okay, For the PCI errors, the way the spec is defined, either all the errors goes to kernel or all the errors goes to out of band or SMM, firmware first or OS. Out of band, I think there's a parallel path there. Sorry, I should take back out of band. Yeah.
Well, but with firmware first, it is up to the firmware first implementation as to whether or not it clears AER registers, for instance, or does anything with them. Now, granted, the BIOS configures the machine when it boots up and it determines how things are signaled, but that's really between you and your BIOS vendor, right?
No, what happens is that if I want to, let's say, partition my PCI errors, correctable errors, I want to route it to kernel OS, right? And uncorrected error to SMM. Today, I can't do that unless I create a very surgical way of under the hood changing some registers.
What can't you
I
do?
would argue the point, Anil, that the idea is those errors are visible. You won't be signaled, but there's nothing that prevents the OS from reading status.
Exactly,
Yeah.
that's the problem, right? And then what happens is, well, actually, it's the other way around. So what happens is that when I give a control to OS, I mean, today the way I'm solving this problem is by giving control to both firmware and OS, kind of in some ways. And then once I boot the machine, then I go in and then change those corrected versus uncorrected device root control, root error control, and root error status control registers to reroute correctable errors only to the kernel, like MSI, and uncorrected errors to SMI. But that's a very funky way of.
Anil, what is the use case or like user scenario, right? Actually, I thought of if you do like uncorrectable errors, okay, to OS, it's more advantage in terms of DPC flows, device level resiliency, PCI device level participate, right? What is
No, so DPC errors are not uncorrected. What you said right, but then you said something which is
no, I'm just giving an example where like you can build the device level. Let's say you get a PCI completion timeout, non-fatal error, right? You can build a device level resiliency.
No, so yes. What happens? So we looked at right. So uncorrected error, we can't guarantee the kernel execution all the time. Some error cases, you're right, but we can't build a solution which fits for all uncorrected errors. So
Neil,
the bigger question is, sorry.
I see a general problem with PCIe that the PCIe spec is really wide open and non-prescriptive.
Thank you.
And yet our software requires certain behavior to run correctly. But that, to me, is completely independent, whether it is in band or out of band.
Yeah.
And I think that is worth discussing here, but I wouldn't couch it the way you've couched it. I would just say PCI configuration is complicated and too wide open, and yet all of us, we kind of run the same kernels and the same, sure, it may be Windows or Linux, but there's not that wide a variety of settings that we really want with PCIe. They shouldn't be wildly different between us. And so if we can drive some commonality and solve some PCIe configuration problems, especially eliminating some of the wide openness of the PCIe spec, that's all good. But I don't couch that argument as in band or out of band. That's like, hey, we got PCIe problems. Let's chat about them.
Sure,
Yeah,
we can put that way. I mean, ultimately, that it boils down to that actually. But
Anil,
you're right. Yeah,
I would just argue that I think that's how we're architected today, is exactly what you're describing, because there is an OSC negotiation.
Thank you.
For AER, right? If the OS gets control of AER and programs, right, then the OS will own everything. However,
exactly.
As a platform, we still configure the system to signal SMI on uncorrected.
Correct.
We allow the OS to do everything, right? But we signal on uncorrected so we can log the event, but then we hand control right back to the OS.
And the OS gets it.
Yes, absolutely. So I mean, that's how we are configured to operate today.
Yeah. So Mark, you must have gone through this problem also, that first of all, you're going to configure both OS through the OSC method, you relinquish the control
Zero.
to the OS. No, actually, sorry, your solution is slightly different than what we are implementing, because you are basically taking full firmware control in the beginning, right? OSC, and then propagating
No, we aren't. I'm saying the OSC method, we allow the OS to take control of AER.
Okay,
And
in that
at
case,
that point, that the OS owns everything. That means it
correct.
programs everything now, but we will still use the hardware to essentially intercept uncorrectable errors when they happen. And the
Yeah.
reason we do that is to manage warranty, right? Means if we have a device failure, we need our log to be populated so our support people will know what failed and what needs to be replaced. But we don't hide anything from the OS in that configuration, right? We simply intercept, capture the data, and then pass control back to the OS. The OS
And that was
then
true.
do the
That was
same.
truly the point of EMCA2, Mark. I agree with you. And so I don't see, that's why I don't see the conflict there.
No. Let me ask you a question, Mark. So once you give the control to the OS, kernel boots, right? Kernel then override the config register, root error status, root error control, and root control register to enable MSI for all 3 error severities. That yes or no?
Yes. Yeah,
Okay.
the OS has that control.
Okay.
And
so once you
if
do
you're-
that,
Well,
once you
if
do
you're
that,
asking, can the OS break the path to the platform? The answer is yes.
exactly.
Yeah.
So now all the uncorrected errors are going to be triggered through MSI. How are you changing that?
No, we're not. If the OS chooses to do that, then essentially it breaks the platform's ability to log the event.
Exactly.
And yeah.
So
And by the way, we know we have seen that. We know it can happen.
Yeah.
But ultimately, this is where we go to our customers that are using that kernel, and to say, look, if you do this, right, it means that the platform will be out of play. And the idea is the platform does provide benefit here, right?
So Mark, you just stop right there. What I would like to drive is a solution where we don't have to go through this choices and all that. Is it enumerated, discoverable, so that at the platform level.
I guess, so Anil, I think the other problem though is we need to say, hey, how do we want URs signaled for our OSs? Because obviously you don't want to take an SMM for every UR, because someone could be walking the bus or rapidly sending an illegally sized transaction to a device and flooding themselves with URs. So maybe we can come back next week, and if you can couch the problem a little bit, like not so much as in band or out of band, but here are the PCIe problems I see. And you can say firmware first is part of it, but I don't think that's an in band out of band problem. That's a firmware first, platform first discussion. And there's just a broader PCIe configuration problem that I'm with you. I'm suffering. I'd love to chat about that. I'd love to come up with, this is the way OSs work. Let's follow these rules so that we just tell all the BIOS vendors and we can write compliance tests, and the PCI configuration is just right for our OSs and VMs, because I don't think they're radically different.
Yeah.
So,
okay.
so
I have
with
it
you,
I have it down. Yeah,
that's a different discussion, though. Do you see why we're scratching our heads? But now that we understand what you want, we're like, yeah, but we need to describe it differently.
Yeah. No, you're right. I was so deep into that I lost track of this is all PCIe specific.
Okay. I'm with you. Yes, 2 thumbs up. Let's do it. Okay.
Yeah,
I need to
and
go
Neil,
too.
I would just argue, I think there's many ways you could get there, even with today's technology. You could simply configure firmware first and then read the status registers off PCI. The idea is, in that mode, we never are going to clear the error conditions. We're always going to pass them on to the OS. So the idea is there's nothing that prevents the OS from coming and reading status to see what errors are present. And the idea is, whenever there's an uncorrectable, the platform will always be there and then hand that event right to the OS. So
yeah, but Mark, but that doesn't work for the correctable error, because you know, if we give the control to firmware, right? Firmware will have to clear the registers to rearm. And
No. You make assumptions there, because the idea is we will typically never signal corrected errors, not unless we have absolute control, and PCI doesn't give us that control. In other words, I'm not going to tie a corrected event on PCI to SMI because I risk, generating an SMI storm. So the idea is we have methods that we use to signal when we think there is a problem, but it would never be on a single corrected event. And yes, it means that there might be a corrected event and it would sit in in status for a long time before we cleared it, but we're never ever going to signal SMI on corrected events.
Okay, so then you're losing the fidelity or the visibility, the fine granular visibility into correctable error behavior of the system.
No, we're not. I can tell you that we just use a different mechanism.
Okay, whatever mechanism you use, we want to define that in the industry, right? And the interface associated with that, so that we don't have to go through this proprietary solution for every customer.
Yeah, I'm just saying, Neil, I think you could get there with today's technology.
Of
What
course,
you want,
we are getting it there.
Yeah.
The problem is I have to write everything on my own, right? Proprietary way. And I'm trying to avoid that. I want to define this interface and modify interface that exists today so that I can just open sources and then let the industry develop the software and everybody use it.
Yeah, I let me just say is I think you have the same problem with memory, right? And I think we have a method that works well also for memory, right? And that, if the user decides to run an OS first, where OS is managing memory, the platform will stay out of the way, but however, right, it will operate as a backstop, so that if there are error conditions that are so severe or present long enough because the OS has not been able to react to them, then the platform will engage. But if the OS does a page retire and we never reach our threshold, the platform does nothing, right?
Mm-hmm.
So it's purely as a backstop. Now, that being said, if a UCNA occurs, we will generate an event, an SMI to the platform, and we'll log it, and then we'll hand it to the OS. And the idea is we do that again for warranty control and management, right? We must be able to identify the DIMM that needs to be replaced, and our support people are looking to our IML and not to the OS, even though the OS is managing memory. If there's an uncorrectable that's actionable, that's a through event. So we will, essentially put the identifier in our log that says, here's a DIMM that needs to be replaced. And right, that's works purely, as a purely collaborative implementation where the platform will react to uncorrectables and potentially to correctables if the OS is unable to. And, but otherwise, we stay out of the way. PCI can essentially be much the same. I think the technique we use is proprietary to Intel. So and you may be aware of it.
I know exactly what you're saying, and
yeah.
That's exactly what I want to avoid.
Yes, but the idea is so from a platform management perspective, there's no way we're going to enter, do an SMI for corrected events happening on PCI. They must be manageable, and the way that they're manageable is by making hardware have threshold controls that are, either essentially platform owned, right? That means the OS can't come in and change them if the platform is programming them. And in essence, the only way you can signal correctables and react to them reasonably is through that method, right? It has to be manageable. There's no corrected source anywhere in the platform that will turn on unless it is manageable.
Yeah.
But I think we are pretty close to what you would desire today, with the caveats certainly that you listed. You know, the OS always has the ability to crater the platform, right? And I just say, you know, when customers, you know, are choosing that, I just say, look, you know, if it hurts when you do this, you know, please don't do that because it hurts, you know. And I think most customers are, you know, willing and amenable to say, okay, we'll use a version of the OS that doesn't turn off error signaling to the platform.
Yeah, I mean, I think we are out of time right now. 8 minutes past. In the enterprise world, Mark, what you guys have come up with a solution, right? It's a very proprietary solution, right? In the OCP world, I'm trying to find the areas where we can build this interface and spec that doesn't require any proprietary solutions.
Well, so I think I'm on board with that. But then what I would say is, to solve the problem that you're talking about, the way to do that is to specify that there has to be hardware that, you know, basically threshold manages PCI Express corrected errors, and that those registers are become part of AER and can be managed by the OS or by the platform, whoever is the owner of AER. And that would be the way to, you know, essentially manage those events. I'm sure there's times when the OS probably doesn't want to get an MSI for every single corrected error, but having that ability in hardware would essentially allow whoever the owner is to manage those events. And
yeah, I mean, that capability would be useful. But again, at the same time, I don't want to preclude a solution where use a host-based capabilities can be developed to monitor literally every error possible, or whatever the fastest possible, and then analyze it and predict certain kind of unique failures that may happen in the future. And the only way you can do that is by trying to have visibility for every error possible, every correctable error possible.
yeah,
Not doing thresholding.
That's right.
Yeah.
Well, the idea is having the threshold controls there, I think, is important, but it's perfectly acceptable if the OS chooses a threshold of 1.
Exactly.
Right?
Exactly. Yeah.
You look at every error, right?
Yep.
And you know, that's okay if you've got the bandwidth and you've got the ability.
There's
there's
plenty
no
of bandwidth.
reason. Yeah.
Bandwidth is
Yeah.
not an issue when you have, you know, hundreds of, I mean, not 100, but, you know, lots of cores.
Yeah, agreed. The idea is that's certainly a choice that can easily be made to get the maximum amount of data, right?
Yeah, yeah. So that kind of solution is hard to build unless we do proprietary way, right? Which we are doing today. But through the OCP community, right? Let's think about how we can define a requirement spec that doesn't require a proprietary solution.
Yeah, I so don't disagree, but I think that's a huge lift, right? It's the idea is it's likely going to need to spec change, and you know, the idea is that can all be done, but man, we're talking glacial speed, right? It
Well, I mean,
happens
let's try. I
years.
mean, yeah, I mean, I agree with you 100%, right? It's not easy. That's the reason I brought it up here, because I was thinking through in my mind, well, yeah, I can do it on my own. I'm doing it right now, right, in my fleet. I mean, it's not easy just to implement on our side also, because we run into the same problem. When we have such a large fleet, right? Everybody asks question, why are you changing it, right? How is it going to affect the other machines which are OEM source, right? And all the kind of questions, right? So one way to solve the problem is by coming together and then making the changes in the specs and filling the gaps in the specs itself. That's the starting point, and then define the API interfaces for implementation. Once we have that, then the industry will open up. Okay, fine, we can develop it, and we can even give some example code also.
Yeah, Well, that's yeah, again, I think that could all happen, but it's probably going to be years in the process to get it, get getting this everybody to agree on the spec change, and but I think if the proposal was for hardware threshold management for errors happening on PCI, I don't know that there would be much pushback on that. I think
Should not
the
be.
industry,
Yep.
yeah, would
Yep.
be on board. So
And-
and then leveraging that to create the environment that you're looking for, it wouldn't be a far stretch after that capability was there.
Good point. Good point. So let me think about it. For next week, I'll put some bullet points of what I think the problem statement is and what kind of direction we can explore, and we'll go from there.
All
Hey,
right, very good.
Hey,
Sorry, I
Neil.
took us
What-
over.
Yeah, one question before you go. Hopefully, I'll make it yes or no. But I mean, if a lot of these registers are industry standard and defined, I mean, would a simple answer sort of be to propose like an open source solution that would just configure things in a certain way? And like Mark said, there's definitely some interesting cases like he talked about, but let me, without going through those, but could you take an existing thing today? Have you guys looked at this and get pretty close with just a current existing release? I'm not, if you make a couple of trade-offs, you might be able to do that. Right?
Yeah,
Like
so
if you,
right. Yeah, we are doing that, right? We were able to do it.
Yeah.
But I have to create kind of my own custom solution, right? And when I have to scale it to, hundred thousands or millions of machines, and maintain it for the next 5-7 years, and there's no guarantee I will be here, right?
Wait,
So-
you've been, wait a minute. No, wait a minute. No.
Right. So something is spec defined implementation is much easier to sustain and scale. That's the key learning I'm having right now.
Right. I think the issue that Anil's always going to have is he might have 12 different vendors of platforms in his fleet.
Exactly.
And even though one might work, he needs all 12 of them to work. And,
Right.
and the only way that happens is if everybody follows the same spec
Exactly.
and
You got
implements
it.
the same way. Yeah.
Yep. Because we have such a huge problem of heterogeneous fleet with all kind of different implementations, and it's just nightmare.
And your problem resonates with me as well. I looked into this like a while back and I took some notes down somewhere, and I was sort of looking at how the ACPI structures are set up, and was there a way, if you came up with like 3 scenarios to reconfigure a system in a way?
I know.
And nobody wants, like, I mean, everyone sort of dug in, like Mark mentioned, there's legacy. So, but then so I guess what I was getting at was that I think that there is like different ways to skin this cat. It's just a matter then of getting people like rallied around what are the ecosystem, what is the trade-off to your ecosystem to get there? And
yeah,
that's
exactly.
a great discussion. So I think it's good.
And I think Drew was mentioning very right thing, that the spec is defined the way, right? It's opened up for all kinds of different implementations, configurations, and fragment the industry, right?
Yeah, and I just brought up open source a little bit just because there was flexibility. So it's like, and like we talked about some of this might take years of industry standard change. So like, could you nudge an open source group in some direction, and then they would start following a path, and then it would be, that would move faster.
Yep.
So
that's exactly I think what we can leverage here, because we have most experts who in the industry are here, right? So if we all agree, then it'll be easier to then influence kernel, Lens kernel team and the PCI SIG and all the other industry board.
Yeah, good.
Cool. Thank you. Have a great weekend. We'll talk again.
All right.
Y'all
Thanks,
too.
Neil.
Bye. Thank you. Bye.